See, in this lecture, we'll solve question number 103, 104, 105. They're fairly simple. They're fairly simple problems of kinematics. Okay, there's nothing to do with much of forces. It's basically how forces and acceleration are related, and how you study the motion. Okay, once you get to acceleration, it's simple kinematics from there on. Okay, so let's start with the first question. Now, in this question, what is being said is that there is a mass m kept on a horizontal ground. Okay, and the coefficient of friction between the ground and the block is given by K. A force is being applied on this block, and this force is variable with time. Okay, this force is variable with time. There will be a friction force acting in the backward direction. Now just start and tell me, as soon as I apply the force, okay, will this block start moving? No. See, this force is going on increasing, no? The block will not start moving till the value of this force is greater than the value of or maximum value of friction force. This block will not never move till the value of F is greater than the value of mu mg or maximum value of friction force. So maximum value of friction force is equals to mu mg. Therefore, the block will not move. The block will not move till F is greater than mu mg. Okay, or At greater than mu mg, or T greater than mu mg by A. Okay, so the block will only start moving after the time exceeds mu mg by A. So let mu mg by A be T1. Let this time be T1. At time T1, force was equals to AT1, and the block started moving at mu mg by AT1. So if the block started moving, it would move with some acceleration. So I need to find out the value of acceleration. So let's draw the equation. Force minus friction force is equals to mass into acceleration. Okay, so out here, if I divide this mass down out here, I'll get At by m minus mu g is equals to acceleration. Now what is acceleration? Acceleration is nothing but dv by dt. dv by dt. So let's substitute dv by dt out here. dv by dt is nothing but acceleration. Can I integrate this entire term with dt? Of course I can. Into dt is equals to dv. Okay, so out here I got this term. Now if I say like this, somewhat like this, at square by 2m minus mu gt plus some constant is equals to v. That means I integrated this entire thing out here. Okay, now my problem is I have to apply the boundary condition out here, no? So let me apply the boundary condition. Boundary condition is at t is equals to this value, the block only started moving at this value, no? So at t is equals to this value, what is the velocity? Velocity is equals to 0, because the block only started when time reached this point. So at t is equals to mu mg by a, okay, v is equals to 0. Obviously the block was at rest before this time also, but in order to find out the value of constant at this equation, we need to put the limiting value, no? And the limiting value is nothing but t is equals to mu mg by a. Okay, so at t is equals to mu mg by a, the block or the velocity of the block just started changing from 0. So put the value of t out here, or a by 2m into mu mg by a square. I'm just putting the value of t square. I'm just substituting the value of t in this equation. Okay, minus mu mg by a plus constant is equals to, what is the value of velocity? 0. So if I solve this equation, the value of constant will come out to be, or constant is equals to half mu square am g square by a. That means if we solve this equation, I solve this equation and find out the value of constant. So out here, velocity is equals to nothing but a t square by 2m, okay, minus mu gt plus half, asha, this mu g square, this half mu square m g square by a can be written as mu m g by a into mu g, okay, and this is nothing but t1. Understood? So this can be written as half t1 mu g, or mu g t1, half mu into g into t1 is equals to velocity. Okay, so this is the equation of velocity. Okay, now from this equation of velocity, okay, I'm just refining this equation. I'm taking a by 2m common from this equation. From the entire left hand side, I'm taking a by 2m common. So out here will be left with t square minus mu gt into 2m by a, okay, plus half mu gt1 into 2m by a, okay, is equals to v. Now what is mgt, sorry, mu mg by a common? What is mu m into g by a? So mu into mg by a is nothing but t1. See, at t is equals to mu mg by a, this is the value of t1, no? Okay, this t1 was substituted by mu mg by a. So out here, this term will become 2t1t. This term will become 2t1 into t. So 2t1 into t. Let me write that 2 at the beginning. Similarly, this term will become what? Mu mg t1. See, mu gm by a. This entire term will nothing but t1. So mu gm by a is nothing but t1. Okay, 2 and 2 will get cut. T1 and T1 is nothing but T1 square. So this entire term will become T1 square. Okay, so if I rewrite the entire equation of velocity, the equation of velocity will become a by 2m into t square minus 2t1t plus t1 square is equals to v. Okay, I'm erasing this part. Now this is nothing but the formula for a minus b whole square. Okay, or a by 2m t minus t1 whole square is equals to v. This is nothing but a minus b whole square formula. Okay, now in the next slide, we'll do what? We'll integrate this equation and find out the value of x. So similarly, so you got the equation of velocity a by 2m t minus t1. Now velocity is nothing but dx by dt. Okay, so if you integrate it, a by 2m into t minus t1 whole square into dt is equals to dx. Now we'll integrate this by integration by substitution. What is substitute? T minus t1 as any other variable p. Okay, or dp by dt. Then we differentiate dp by dt. That means we differentiate this with respect to t is nothing but 1. So from this equation, or dp is equals to dt. Okay, so we substitute both these values out here. Okay, or this method is known as substitution integration by substitution. T minus T1 is nothing but P. Okay, T minus T1 is substituted as P into dt is substituted as dp. See, dt is equals to dp is equals to dx. Okay, or if I integrate this one, this is nothing but a by 2m p cube by 3 plus some constant is equals to dx. Now you can either solve for constant out here, or you can expand the p then solve the value of constant. Both will come as same till you put the boundary condition correct. Okay, whatever value or whenever you expand it or whenever you write down the equation, both will be correct. So I'm just expanding this equation and then putting out the boundary condition. See, t minus t1 cube by 3 plus some constant is equals to x. Achha, out here it won't be dx, it would be x. Since you already integrated dx, integration of dx is nothing but x out here. Okay, now 3 into 2 multiply and we get 6. Okay, what is the value of constant? See, the boundary condition out here at t is equals to t1. Okay, x is equals to 0. So when you put t is equals to t1 out here, that means at the starting of motion, when will the motion start? When the value of t reaches t1. So when you put t is equals to t1 out here, what will become? This entire term will become 0 and x will become 0. So the value of constant out here is 0. So the displacement of x is given by a by 6m into t minus t1 cube. This is the displacement from time t. In this question, a ball is projected from the ground vertically upward with velocity v0. Okay, so it went up, then after certain distance it came down. The question is asking find the velocity of the ball when it came down. Okay, this velocity. So your first intuition should be, if the velocity while going up is v0, velocity while coming down should be v0, same thing. But in this question there is a twist out here. The twist is that air friction forces is acting on the ball. Air friction is nothing but air drag forces. Whenever you hear drag forces is nothing but air friction forces, or fluid friction forces are called drag forces. Okay, and one more note, fluid friction forces or drag forces always acts opposite to the direction of velocity of body. Drag forces always act opposite to the direction of velocity of body. Okay, so we need to find out the velocity while it came down out here. So in order to find out the velocity, we need to find out the maximum height till which it reached. So let that be h. And we need to divide this problem into two parts, while going up and while coming down. Why? Because while going up, friction force will be acting downward, mg force will be also acting downward. So the acceleration will be of one equation. But while coming down, okay, while coming down, the friction force will be acting upward, or air friction force will be acting downward. Why? Because velocity is downward and gravity force would be acting downward. So while going up, air friction and both gravity would be acting downward. While coming down, gravity is acting downward while friction force is acting upward. So while going up, okay, let me draw the free body diagram. Out here, upward velocity is v0. There is a gravity force of mg and a drag force of kv square, or a friction force of kv square, which causes an acceleration in downward direction. Now see, this drag forces is variable in nature. That means as the ball goes upward, its velocity decreases, and as the velocity decreases, this friction force or air drag force also decreases. So how do I solve it? Simply write down the equation. or kv square plus mg total force is equals to mass into acceleration. Okay, divide the entire thing by mass. Okay, so this mass, this would get cancelled, m and m would get cancelled. So can I erase this one? Now acceleration can be written as v dv by dx. Why am I doing it? Because I'm trying to find out the maximum height. For that, I'll get a relation between v and displacement, and we always know at maximum height the velocity would be equals to 0. Okay, so I've written acceleration as a is equals to v dv by dx. So let me write this one, v dv by dx. Okay, now can I multiply this dx? So, or is equals to dx is equals to v dv by kv square by m plus g. Okay, I have sent this entire term dx to the left hand side and this entire term to the denominator out here. Okay, and you have to integrate. In my integration, the limits out here doesn't matter because I'm doing indefinite integral and putting up the boundary condition out here. Okay, so you can simply integrate. But in my condition, you have to put an additional value of constant and find out the value of constant by boundary condition. So out here, this kind of integration from the topic of mathematics is called integration by substitution. Okay. So in this type of integration, what do you do is you assign certain variables out here. Okay, such as, you can learn it from the topic of mathematics, but I'll just give you a brief. Okay, integration by substitution. Okay, so out here, the thing that is to be substituted is kv square by m plus g is equals to, let's say, any variable p, m, whatever you use. Okay, so this variable is substituted as p. So out here, can I say dp by dv? dp by dv. What I'm trying to do is I'm trying to differentiate this entire equation with respect to v. So it will be nothing but 2k by m v is equals to dp by dv, or 2k by m v dv is equals to dp, or v dv is equals to how much? dp into m by 2k into m by 2k. So our main method out here, this complex problem solved out to be, this entire value came out to be p. See, this entire value is nothing but p, and this v dv is nothing but dp into m by 2k, but m and 2k are constant. So out here, this is nothing but m by 2k into dp. Now is this integration manageable? See, if I rewrite this integration, dx is equals to m by 2k dp divided by p. So this integration is obviously manageable. So if I integrate this one, it would be x is equals to m by 2k ln p. So after writing or after integrating it, see, p was the variable we introduced, no? And what was p? P was nothing but this variable. So again substitute back the variable out here. So out here, p is nothing but, the value of p is nothing but how much? Ln p. P is nothing but kv square by m plus g. So we're writing out here p is equals to kv square by m plus g. And whenever we do indefinite integral, we always add a constant. Okay, so the out here constant is added. Now this is the equation of displacement while going up. Okay, this is the equation of displacement while going up. To find out the value of constant, you need to put up a boundary condition. So boundary condition out here is at x is equals to 0. Okay, that means at this point when the body has just started moving at x is equals to 0. velocity is equals to v naught. Velocity is equals to v naught. Why? Because the initial velocity at the starting was equals to v naught. So put these two values out here. What do we get? We'll get something like, see, this is the equation. Acha, I'm erasing everything out here. Okay. If you put x is equals to 0 and v is equals to v naught in this equation, you get 0 is equals to m by 2k ln k v naught square by m plus g plus constant is equals to 0. So constant is nothing but, or constant is nothing but minus m by 2k ln k v naught by v naught square by m plus g. So can I write here the equation? If I substitute the value of constant by this value, if I substitute the value of constant by this value, I'll get the equation at displacement as x is equals to m by 2k ln k v square by m, where v is the velocity at that point, at any point, minus m by 2k ln k initial velocity square by m plus g. Okay, in this equation, can I take m by 2k common, or x is equals to m by 2k ln, just ln a minus ln b is equals to ln a by b. I already know that. So k v square by m plus g divided by k v naught square by m plus g. So this is the equation. Now need to find out what is the value of h. So using this equation, if I put the value of h out here, can I get the value of v? What is the value of v at topmost position? The value of v is 0. So if I put the value of v is equals to 0 out here, I'll get the value of h. Now we need to find out the maximum height. Okay. So for maximum height, we put the boundary condition to at x is equals to h, v is equals to 0. That means at maximum height, the velocity becomes 0. Now put x is equals to h out here and v is equals to 0 out here. Okay, we get the equation h is equals to m by 2k ln, this entire terms become 0. So is equals to g by k v naught square, where v naught is the initial velocity, by m plus g. Okay, so the maximum height is given by this equation. H is equals to m by 2k ln g by g. Now while coming down, while coming down, okay, so while coming down, the ball is at topmost position, okay, at height h. We need to find out the velocity when it is the bottommost point, velocity out here. Okay, what are the forces acting on this ball? Mg. Now what is the direction of drag force? The direction of drag force would be upward, kv square. Why? Because drag force is always opposite to the direction of velocity. While coming down, the velocity would be downward, so drag force would be upward, is equals to acceleration. So similarly, if you write this acceleration, or if you write this equation, mg minus kv square is equals to mass into acceleration. Similarly, we substitute acceleration is equals to v dv by dx. We'll get the equation. See, if we follow the same protocol, we'll get the equation some. So if we solve this equation, we'll get the value of x is equals to this value while coming down. Now to find out the value of boundary condition, or to find out the value of constant, we need to put a boundary condition. So boundary condition 1, at x is equals to 0. Okay, that means when the ball is at out here, you are now assigning this as the origin. At x is equals to 0. Okay, what will happen to the v? V is equals to 0. See, you can do this opposite calculation also. Okay, at x is equals to h, v is equals to 0, and you can find out the value of constant by their parameter also. But the calculation will be a little bit more lengthy. Okay, So if you put x is equals to h, v is equals to 0, to find out the velocity v or boundary condition 2, you have to put x is equals to 0. Okay, same thing. You can either put x is equals to 0, v is equals to 0 out here. Then you have to put x is equals to h, v is equals to what value? Or either x is equals to h, v is equals to 0, then out here x is equals to 0, v is equals to what value? Understood? Both will have the same answer. So I'm taking x is equals to 0, v is equals to 0 out here. So I'm considering my origin out here. It doesn't matter where you consider the origin. The answer will come out to be same. So as soon as you put x is equals to 0 and v is equals to 0 out here, we get the value. The constant will come out as minus m by 2k ln g. See, if you put v is equals to 0 and x is equals to 0, the value of constant is equals to m by 2k ln g, and m by 2k ln g will be sent to that side and become minus m by 2k ln g. So the value of constant out here, or the equation of motion during downward motion, becomes m by 2k ln g minus kv square by m divided by g. Okay. Okay. Now boundary condition 2. Boundary condition 2 is at x is equals to h. So when the body is the downmost position, what is the velocity out here? So at boundary condition 2, okay, at x is equals to h, find v or isolate v. Okay, similarly out here. So now in this equation, if you put x is equals to h, you need to find out v is equals to what? So x is equals to h is equals to m by 2k ln g minus kv square by m divided by g. Okay, we need to find out the value of v out here. So first we need to substitute the value of h. What is the value of h? The value of h is nothing but this value. So h is nothing but m by 2k ln g by k v naught square by m plus g. Okay, so out here, if we rewrite this equation, this would be equals to h, which is h is equals to m by 2k ln g by k v naught square by m plus g. Okay, now can I cancel? See, let me rewrite this. Let me erase this one. I just substituted this one. Okay, can I cancel m by 2k from left hand side and m by 2k from left hand side? Obviously. Now ln a is equals to ln b. So can I say a is equals to b? Obviously. So a is equals to b. Okay. Now can I cross multiply g with g and this entire value with this entire value? So if I cross multiply, I'll get g square is equals to g minus k v square by m into k v naught square by m plus g. Okay, or g plus k v naught square by m. G plus k v naught square by m. Okay, this v out here and this v out here is different. So let me erase this one. Now let me expand this value. G square is equals to g square g into g plus g into k v naught square by m plus g into k v naught square by m minus g into k v square by m minus g into k v square by m. Okay, minus k square v naught square by m square. I multiply these two, k square v naught square by m square. Okay, now I'm cancelling out g and g. Okay, g minus g square minus g square is equals to 0. So out here 0 is equals to v. Okay, now what do? I need to isolate the value of v square. Okay, So out here, these two are the only terms that contains v square. So if I take these two terms to the left hand side, what will become? Gk v square by m, or if I take this entire left term, these two terms to the left hand side, it will become g plus kv square is equals to this value. Okay, I'm dividing the entire term by g, divided by g, divided by g, divided by g. G gets cancelled. Okay, so g and g got cancelled. Now I'm multiplying the entire term by, okay, I'm multiplying all the now what do I do? I'm taking v square common out here. Okay, so if I take v square common out here, what do I get? V square, v square. So I got v square common out here. Okay, now what do I do? I can also take k by m common from these two parameters, no? So if I take k by m common outside, k by m, this will become 1 and this would become k and m. Okay, I just took k by m common. Okay, now this k by m and k by m would get cancelled. So out here, this value and this entire value is getting cancelled. Let me rewrite this properly. 1 plus k v naught square by mg. So 1 plus k v naught square by mg. 1 plus k v naught square by mg into v square is equals to v naught square, or out here v square is equals to v naught square divided by 1 plus k v naught square divided by mg. Okay, and if I put under root to both left hand side and right hand side, I'll get v is equals to v naught square under root of v naught square 1 plus k v naught square by mg. So the velocity while coming down would be this value. This is the value of velocity while the block is coming down. Understood? So in this question, what is being said is that there is a particle of mass m. Okay, and a force is acting on this particle. Okay, a force is acting on this particle. See, the magnitude of this force is constant. Okay, but what happens? This force keeps rotating with uniform angular velocity. So although the magnitude of this force is constant, this force keeps rotating with uniform magnetic field, uniform angular velocity. Okay, so after some time, the force will act in upward direction. Okay, after some time, the force will act on left side direction. After some time, the force will act on downward direction. The magnitude of the force will be same. The question is asking find the velocity as a function of time. Okay, provided we know at t is equals to 0, the particle was at rest. That means at t is equals to 0, v is equals to 0. Okay, assume the particle to be stationary at t is equals to 0. That means at t is equals to 0, v is equals to 0. Okay, so how do we solve this kind of question? So the first thing that we must do is we must assign a coordinate system. So I'm assigning this to be x, or this axis to be x, and the perpendicular axis to be y. This axis to be x axis, and y axis. Now let's put the body out here. Okay, our mass m and this force vector is rotating with omega, or say constant angular velocity. So after a certain time, what will happen? The force will go out here, or the force will come out here. Okay, so say after certain time, the force reached out here. Okay, initially the force was at x axis. After certain time, the force reached out here. The magnitude of the force will remain constant. and it is making an angle theta is with the x-axis. Now, if the force was rotating with angular velocity omega, can I say theta, or can I write theta in terms of omega? How? We do know that theta is equals to initial angular velocity into t plus half alpha t square. Okay, and since the force is rotating with constant angular velocity, so there is no acceleration out here, so this entire term would be 0, and the angular velocity is constant, which is equals to omega. So theta is equals to omega t. Theta is equals to omega t, where t is the time after 0 second. So the angle turned after 0 second is nothing but angular velocity of the force into time for which you are calculating the angle, omega t. Okay, now see, what is the x component of force? X component of force is nothing but f cos theta, f cos theta, okay, or f cos omega t. Similarly, what is the y component of force? Y component f sin theta, or is equals to f sin omega t. Okay, is the force rotating in, the force is rotating in xy plane only, so there is no z component. So can I write force vector is equals to f cos omega ti plus f sin omega t j. Okay, now see, the question became more manageable. A block of mass m is acted by a force of this magnitude. So what is the acceleration? Acceleration is nothing but, we know that force is equals to mass into acceleration. This force is nothing but mass into acceleration, which is equals to f cos omega ti plus f sin omega tj, sin omega tj. Now can I divide this? If I divide this mass out here, mass out here, and mass out here, I get this value. Mass is a scalar quantity. Okay, so we got the value of acceleration, this one. Okay, and what is acceleration? Acceleration is nothing but dv by dt. So dv by dt is equals to this entire value. This entire value, so I'm substituting this by dv by dt. dv by dt. Okay. Now can I send the dt to the right hand side? Of course I can send the dt to the right hand side. See, I can do it separately also. I can do the x component of velocity, y component of velocity. For x component of velocity, you just take this much part. For y component of velocity, you just take this much part. You can do it separate also, you can do it together also. Just maintain the vector quantities. Okay. So out here in this equation, can I send the dt to the right hand side? Of course I can. So into dt into dt. So dv is equals to this value. Okay. Now can I integrate this with dt and this with dt? Of course I can. So v vector is equals to f by m cos, acha, what is the integration of cos omega t? F by m omega sin omega t I plus constant I, that means constant of integration of I component. Okay, plus f by m omega cos omega t j. Okay, out here it should be minus integration of sin omega t is nothing but minus cos omega t plus constant of j, constant of j. You can, instead of writing constant of I and constant of j, you can do it by single constant and put out the boundary condition. Okay, whatever value of constant comes out, that will be nothing but, you can substitute the constant by that value. So it doesn't matter if you do constant of I or constant of j, or substitute by single constant. Okay, the method doesn't matter out here. The boundary condition out here matters. Okay, so you must solve this equation with a boundary condition. So let's write this equation on the next page. Now the boundary condition that we have out here, boundary condition at t is equals to 0. Okay, Vx or velocity of component of x is equals to 0, velocity component of y is equals to 0. Okay, so out here y, see, assume the particle to be stationary at t is equals to 0. So in the question it is given at t is equals to 0, v is equals to 0. The net component of velocity is equals to 0. So similarly, if we apply this t is equals to 0 out here, okay, the constant of I becomes 0. See, v or vx is equals to 0. Okay, 0I plus 0j. Okay, that is nothing but v is equals to 0 is equals to f sine omega t. If you put t is equals to 0, entire conditions become, or this entire terms become 0. So 0I plus constant of I, okay, minus, if you put t is equals to 0 out here, this entire terms becomes minus f by omega, minus f by m omega j plus constant of j. Okay, so out here this is nothing but constant of I is equals to 0. Okay, see, compare these values. 0I is equals to 0I plus constant. So constant of I is equals to 0. Constant of j, 0j minus f by m omega j is equals to constant of plus constant of j. So out here constant of j is nothing but f by m omega. Okay, f by m omega j. So out here if I rewrite the equation, f by m omega sine omega ti is no constant of I minus f by m omega cos omega tj, and what is constant of j? Plus f by m omega constant of j. Okay, so if I take f by m omega common out here, there's no need of doing vectors out here, no need of doing vectors. Or v vector is equals to f by m omega, okay, sine omega ti plus 1 minus cos omega t j. This is the function of velocity with respect to time. Now your answer is given in terms of the magnitude of this vector. Magnitude of this vector is nothing but f by m omega. See, out here also m omega will get multiplied this, f by m omega will get multiplied by this also. So if I take f by m omega common and take it outside the under root, it will be f by m omega only. Okay, under root of x component of velocity square plus y component of velocity square. So sine omega t whole square plus 1 minus cos omega t whole square. So if I expand this, or magnitude of velocity is equals to f by m omega, okay, sine square omega t plus 1 plus 1 minus 2 cos omega t plus cos square omega t. Okay, what is sine square omega t plus cos square omega t? Sine square omega t plus cos square omega t is nothing but 1, or v is equals to f by m omega under root of sine square omega t plus cos square omega t is nothing but 1 plus 1 minus 2 cos omega t. Okay, 1 plus 1 is nothing but 2. Okay, if I take 2 common from both sides, 2, so it would be 1 minus cos omega t. 1 minus cos omega t. Okay. Now from trigonometry, we know that cos omega t can be written as cos 2 into omega t by 2. Okay. Or 2 into omega t by 2 can be written as omega t by 2 plus omega t by 2 plus omega t by 2. Isn't it? Okay. What is cos a plus b? Cos a plus b from trigonometry is nothing but cos a cos b minus sin a sin b. Okay. Simply, if we apply that formula out here, so cos omega t by 2 plus cos omega t by 2, or cos omega t is equals to cos a cos b. Cos a cos omega t by 2 into cos omega t by 2 is nothing but cos square omega t by 2. Okay, minus sin omega t by 2 into sin omega t by 2, sin square omega t by 2. Okay, so out here, if I apply the formula, I'm just expanding this much term. Okay, not writing the whole term out here, because out here 1 minus cos omega t. So 1 minus how much? Cos square omega t by 2, cos square omega t by 2 minus sine square omega t by 2. Okay, so out here, if I open the bracket, what will happen? This minus will turn to plus out here. So sine square omega t by 2 plus cos square minus cos square omega t by 2. Okay. We also know that 1 minus cos square omega t by 2 is equals to sine square omega t by 2. Why? Because suppose if I rub this one, okay, so sine square theta plus cos square theta is equals to 1. So sine square omega t by 2 plus cos square omega t by 2 is equals to 1, or 1 minus cos square omega t by 2 is equals to sine square omega t by 2 cos square omega t by 2. So this entire value is nothing but sine square omega t by 2. So this entire value is nothing but sine square omega t by 2. So out here, if I substitute this entire value by sine square omega t by 2, I'll get this one. So sine square omega t by 2 plus sine square omega t by 2 is nothing but 2 into sine square omega t by 2. So is equals to 2 into sine square omega t by 2. So this entire term will get replaced by 2 into sine square omega t by 2. Okay, let me erase this one, and let me also erase this one. Okay, now if I calculate magnitude of velocity is equals to f by m omega under root, if I take this under root outside, it will be 2 into sine omega t by 2, or 2f sine omega t by 2, or 2f by m omega sine omega t by 2. This is the magnitude of velocity, and magnitude of velocity is also known as speed, is equals to speed, instantaneous speed. Instantaneous velocity is always equals to instantaneous speed. Now from this equation, we got the equation of speed. Okay, the second part of the question is asking the distance covered by the particle between two successive stops. Okay, so for distance, we need to integrate the speed, not velocity. Okay, to calculate distance, distance is nothing but rate of change of speed. So distance is nothing but d of speed divided by dt. Okay, so we got the value of speed. So we'll solve this second part of the question in the next question. Now we know that instantaneous magnitude of instantaneous velocity, which is equals to speed, is equals to rate of change of distance by time. Okay, okay. So if I write this, or if I substitute speed by 2f by m omega, which is the magnitude of instantaneous velocity, which is also the instantaneous speed, is equals to d distance over dt. Okay, can I send dt to the left hand side? So if I write equals to little bit close, can I do like this dt? Okay, so out here. Now if I integrate this equation, I'll get the value of distance. So integration of this is nothing but 2f by m omega, okay, into minus 2 by omega cos omega t by 2 plus some constant is equals to distance, or 4f by m omega square minus 4f by m omega square cos omega t by 2 plus constant is equals to distance. Now to find out the value of constant, need to put out the boundary condition. So at x is equals to 0, distance is equals to 0. So sorry, at x equals to 0 or at t is equals to 0, distance is equals to 0. At time t is equals to 0, that means at initial moment, distance is equals to 0. So put the value of t0 out here. If you put t0 out here, what will get? This entire term would become 4f by m omega square. Cos of 0 is nothing but 1 and distance is nothing but 0. So if you put this boundary condition in this equation, the value of constant will come out as 4f by m omega square. So out here, distance is equals to minus 4f by m omega square cos omega t by 2 plus 4f by m omega square is equals to distance. Okay, so if I take 4f by m omega square common, it will be, or distance is equals to how much? 4f by m omega square 1 minus cos omega t by 2. This is the distance traveled in time t. Now this is the equation of distance out here. Okay, this is the equation of distance. The question is asking the distance covered by the particle between two successive stops. Okay, so when does the particle stop? The particle stops when speed is equals to 0. So when this value is equals to 0, so this value will only become 0 when sine omega t by 2 is equals to 0 or pi. So this value will only become 0 when omega t by 2 is equals to 0 or pi or 2 pi, okay, or 3 pi. At natural numbers of multiples of pi, this value will be 0. Okay, so at the starting, at t is equals to 0, we got the speed is equals to 0, and at omega t by 2 is equals to pi, we even get speed is equals to 0. So that means two successive stop is nothing but between omega t by 2 is equals to 0 to pi. Okay, so we have to calculate the distance at t is equals to 0. At t is equals to 0, distance is equals to 0. We got our first boundary condition. So at when does the particle stop the next time? At between t is equals to 0 or omega t by 2. Omega t by 2 is equals to 0 and omega t by 2 is equals to pi. Why? Because sine of 0 is 0 and sine of pi is also 0. Okay, so between t is equals to 0, between omega t by 2 is equals to 0 or t is equals to 0 and omega t by 2 is equals to pi, or time is equals to 2 pi by omega. Okay, what is the value of distance at t is equals to 2 pi by omega? So distance is equals to 4f by m omega square 1 minus, if I put 2 pi by omega out here, okay, it would be cos pi. Cos pi out here. The value of cos pi is nothing. The value of cos pi is nothing but -1. Cos pi is nothing but -1. So if I erase this and make it cos pi is equals to -1, I'll get distance is equals to 4f by m omega square into 1 plus 1 is nothing but 2, which is equals to 8f by m omega square. So distance traveled over two successive stops. That means between t is equals to 0 and the next time it stops. When does it stop for the next time? At omega t by 2 is equals to pi. At omega t by 2 is equals to pi. But t is equals to 2 into pi by omega. The fourth part of the question was find the mean velocity over this time. So B part 2. Mean velocity, mean speed. Okay. Out here it is asking for mean speed. Answer is written in terms of mean speed. Is equals to total distance traveled by total time. Okay. What is the total distance traveled? 8f by m omega square. 8f by m omega square. What is the total time? 2 pi by omega minus 0 is equals to 2 pi by omega. 2 pi by omega. So mean speed is equals to 8f by m omega square divided by 2 pi by omega. So omega and this would get cancelled, 2 and 4 would get cancelled. So our answer would come out as divided by pi. Okay, 4f by m omega pi.